Welcome to all the participants and the different persons which are joined here in that particular session on value added certificate course, which is been organized by the Department of Chemistry, Pandit NRS Government College, Rohtak, under the aegis of Directorate of Higher Education, Haryana. So first of all, I wish to give my sincere thanks to the Department of Higher Education, Haryana, Panchkula, for giving us the opportunity to organize such programs. Along with, I also wish to give my sincere thanks to our principal sir, worthy principal sir, Major Dinesh Saharan, who always supported us for organizing such type of programs. It gives me immense pleasure to welcome the Dr. Sujata Sengupta, who is currently working as an assistant professor, Miranda House, University of Delhi. I also feel proud, my hearty welcome to you, ma'am, on behalf of all the participants, our college fraternity, our Department of Chemistry, because we are going to be benefited with your expertise. Dr. Sujata Sen Gupta completed her UG degree, their bachelor degree in chemistry from a very renowned college, that is the Miranda House, University of Delhi. She completed her master's degree in Department of Chemistry, University of Delhi. She obtained her PhD degree, doctorate degree in the field of synthetic organic chemistry from West Virginia University in Morgantown, USA. In addition, she has worked as a junior research scientist at Dr. Reddy Laboratory Limited, Hyderabad, India, where she was involved in the synthesis of novel drug candidates. She has successfully published various research papers in the reputed international journals. Dr. Sujata Sen Gupta has an extensive, valuable teaching experience in both UG and the PG level at both national and the international universities. She has been an adjunct professor of chemistry at Marymount University, USA, and an ad hoc faculty at the Department of Chemistry, University of Delhi. As I already told you, currently Dr. Sujata Sen Gupta giving their valuable experience of teaching at Miranda House, University of Delhi since 2016. In addition to the teaching organic chemistry classes, Dr. Sujata Sen Gupta is passionate about the green chemistry, which is the need of the hour. She has co-authored a book titled Green Chemistry, an introduction aimed for the undergraduate students at the University of Delhi. I would like to mention that our theme is also one of the highest priority of government of India and remains one of the key challenges to the whole society. I am sure that the inputs and the guidance given by you, ma'am, in this session will go a long way in enriching our efforts for making meaningful changes in the life of peoples. Thank you so much, ma'am, and welcome again to be a part of this session by accepting our invitation on such a short call. Now I request Dr. Sujata Sen Gupta to enlighten us with her precious, valuable experience and knowledge. Over to you, ma'am.
Hello everyone. I would like to begin my talk by first thanking Dr. Ravinder Singh and the Department of Chemistry at Pandit Neki Ram Sharma Government College, Rohtak for organizing this value added certificate course under the aegis of the Directorate of Higher Education, Haryana, and for inviting me to deliver this talk in their series of Chemistry in Everyday Life. I am truly happy and excited to be a resource person for this program. Today, my talk will be on the chemistry of terpenes, terpenoids, and essential oils and how they are used in our everyday life. My talk will have the following areas. I will begin with a brief introduction. Then we will move on to what are perfumes, essential oils, the main components of essential oils, terpenes, terpenoids, what are their methods of extraction, and two important essential oils which are commonly used in India. So first of all, let us begin with the chemistry of fragrances. So the culture of fragrances or the use of fragrances, it is actually traced back to the ancient times. Egyptians, Greeks, Chinese, and even the Indians have all been interested and have developed this art of aroma. And scents like jasmine, rose, sandalwood, they have even been narrated in the Vedas. So this word perfume actually it comes from a Latin word which means per fum, and this means through smoke. So what it basically refers to are those substances which will emit and diffuse a very pleasant and fragrant odor. And actually, till the 19th century, the use of perfumes was actually limited only to the wealthy people. And this is because most of the perfumes at that time they were an amalgam of natural ingredients which were obtained mostly from plant origin, and together they would produce a unique scent. But because they were from plant origin, so these substances were in limited supply, and the techniques that were used for their isolation, that was very difficult. And as a result, poor yields were obtained and the perfumes would actually be very expensive. But nowadays what happens is most of the perfumes that we use, these are actually mixtures of both natural compounds being the natural essential oils, along with synthetic aromatic compounds. Okay, and that is why they are much more cheaper these days. And a perfume actually it consists of three basic components. The solvent, the fixative agent, and the odor bearing compound. And we will talk about this in the next few slides. So as I mentioned, the perfume that we use today, it consists of three basic components. The solvent. The solvent is primarily, it is a mixture of alcohol and water. A fixative. Fixatives are basically natural or synthetic substances which are used to stabilize the vapor pressure, and it enhances the overall odor of the product. And finally, it consists of the essential oils, and essential oil is nothing but it is a complex mixture of our odor bearing compounds. So these are the compounds which are actually responsible for producing the fragrance or the perfume or the scent in these products. And today these perfumes, these are used everywhere. They are used in cosmetic products. We find them in soaps, detergents, and even many pharmaceutical formulations also have perfumes and odor bearing compounds in them. Now let's move on to what are essential oils. So actually more than 4,000 aromatic and medicinal plant species are known till date, and they provide these essential oils which have now become an important source of fragrance and flavoring chemicals which are used in the perfume industry, the food industry, and in the pharmaceutical industry. So essential oils are nothing but a complex and diverse group of volatile and aromatic compounds which are produced in the living organism, and primarily they are of plant origin. Now chemically, the essential oils, they are mixtures of several aromatic or odor bearing compounds, and these will include compounds like terpenes, terpenoids, and compounds such as phenyl propanoids, benzenoids, and even low molecular weight aliphatic hydrocarbons. These essential oils, they are colorless and they are mostly volatile liquids at room temperature. They are also actually secondary plant metabolites, and besides having an odor, they are also important or plays key roles in various other functions like the plant's defense mechanism and various signaling pathways. These essential oils, they can actually be isolated from varying parts of the plant. So for example, the sandalwood oil, which is one of the most expensive essential oil, this is most commonly isolated from the bark of the sandalwood tree. Um, then lavender oil, rose oil, these are all essential oils which are isolated from the flowers of the rose plant and the lavender plant. And the peppermint oil, it is actually isolated from the leaves of the mint plant. So these oils are isolated from varying parts of the plant, and a variety of methods actually exist for the extraction of these essential oils. These can include chemical methods like steam distillation, solvent extraction, or they can be mechanical methods, for example, like expression, where it is extracted from the petals or the fruit peels by physically crushing them, or by the enfleurage method where the essential oil is trapped within layers of fat. So these methods will be discussed in details during the later part of this talk. So in this table, you can see that I have listed for you the 12 common essential oils. What are their major methods of isolation, which we will talk about in the later part. Which part of the plant they are isolated from, whether the leaves, the grass, the bud, the peel, the seeds. What is their major chemical constituent? So chemically, what is that major odor bearing compound, and where that essential oil is actually used? And you can see the use of essential oils are as flavoring agents. They are used as in the disinfectant industry, perfumes. They are even used in dentistry, for example, like clove oil. Alright, and even like eucalyptus, which is used as a decongestant, like in the Vicks vapor rubs and so on. So now coming to uh, what are the various odor bearing compounds. So as we know so far, essential oils are basically concentrated hydrophobic liquids containing a volatile odoriferous compounds which are derived from the various parts of the plant. Now, a particular essential oil, it can either be composed of several components in a varying composition, where two or three are the major components which are going to be present at a very high concentration compared to the other components which will only be present in a trace amount. Now, according to the chemical structure, these odor-bearing compounds, these are actually divided into four major groups: the terpenes, the terpenoids, the phenyl propanoids, and compounds which belong to the category of others. And in the others, these will include the benzenoids and other low molecular weight aliphatic hydrocarbons. And furthermore, these components, they consist of various functional groups. They can be oxygenated compounds, and in certain cases they might also contain sulfur and nitrogen. So terpenes actually constitute the largest group of the natural fragrances. Chemically, terpenes are a class of secondary plant metabolites. They are actually a class of hydrocarbons and which occurs widely in plants and in certain cases in certain animals. Their classifications or terpenes are classified on the basis of the number of isoprene units. So here I have isoprene or the IUPAC nomenclature is 2-methyl-1,3-butadiene. So terpenes are nothing but natural polymers of this isoprene. And the isoprene, it actually has a head and it has a tail. And the isoprene rule, it dictates how the isoprene units are going to be joined together in a head-to-tail configuration. So the tail of the first molecule, it joins the head of the second molecule to form a larger unit. Now, the terpenes, like I said, are classified on the basis of the number of these isoprene units. If they can be hemiterpenes, where there is only one isoprene unit, the simplest one. Then we have monoterpenes, 2 isoprene units, sesquiterpenes with 15 carbon, diterpenes with 20 carbon. The monoterpenes, the diterpenes, and the sesquiterpenes, these are actually the most abundant in the essential oils from the plants. The simplest example of a terpene is myrcene, and this is a substance which is very commonly used in numerous flavor and fragrance chemicals. Pinene is another alpha pinene or beta pinene. So pinenes are a collection of unsaturated bicyclic monoterpenes. These are found in two geometric isomers, the alpha pinene and the beta pinene, and this is a major component found from the coniferous trees, and they are the primary constituents of the turpentine oil. And limonene over here, it is a monoterpene terpene, and it is actually formed by the combination of two isoprene units, and it is a essential oil, or it is a component which is very commonly found in the peels of the citrus plants. Terpenoids are oxygenated derivatives of terpenes, and this is another major component of our essential oils. So over here you can see various oxygenated forms of the terpenes, and these are called as our terpenoids. So menthol is a monoterpenoid, and it is obtained from the oils of the peppermint oil and other mint oils. Thymol over here is also a natural monoterpenoid phenol derivative, and it is found in the oil of thyme, and it is extracted from the Thymus vulgaris plant and also from the ajwain plant. Camphor, this is something that we already know. Camphor we all use. It is also an example of a monoterpenoid and a cyclic ketone, and it is commonly obtained from the wood of the camphor laurel tree, or the found in East Asia, or the kapur tree found in India. And then we have the citronellal. So the citronellal, these are also monoterpenoid aldehyde. So these are monoterpenoid aldehydes, and these are compounds which is commonly found in the citronella oil, which has a very distinct lemon scent, and we know that these are typically used. They have very good insect repellent properties, and so that is they are widely used, especially in your anti-mosquito ointments like Odomus and so on. The ionones, these are actually a group of monoterpenoids again, which are commonly found in rose, and particularly this beta ionone. It is responsible for the distinct scent of the rose flower. Besides terpenes and terpenoids, so there are other compounds like I mentioned, which are responsible for odor bearing compounds. Of these will include the esters of anthranilic acid, salicylic acid, and benzyl alcohol. So these fall under the class of benzenoids. Among them, most important perhaps is methyl salicylate, which is the oil of wintergreen, commonly used in move, iodex, and other pain relieving ointments. And then we have compounds like eugenol, anethol, myrcetin. These are all examples of compounds which are known as phenyl propenoids. And phenyl propenoids are another class of secondary plant metabolites, and they are a diverse group of compounds which not only give a distinct smell, have odor, but these are also involved in the plant's defense mechanism, and also provide structural support and are required for the overall survival of the plant. The major methods routinely used for the isolation of the volatile oils from the plants, these include expression, distillation, extraction with volatile organic solvents, and adsorption in purified fats known as enfleurage. Solvents such as hexane, purified petroleum ether, ethanol, these are typically used for the extraction of the essential oil from the plant material by the solvent extraction method. This is one of the most common and economically important techniques for the isolation of the essential oil. And in this method, the raw plant materials, they are submerged and agitated in the suitable solvent to allow the dissolution of the odor-bearing component. And a typical solvent extraction method, it will first involve the treatment or the agitation of the plant material with a suitable organic solvent. The desired aroma containing compounds, they dissolve in this organic solvent, after which the solution of the aromatic substances, they are evaporated to produce a component known as the concrete, also known as the concrete. And this concrete is actually a waxy semi-solid residue which contains the essential oil, but it also contains waxes and resins. This concrete is next going to be mixed with the alcohol and is then heated, uh, mixed with the alcohol and is then going to be heated. Later, the alcohol is then going to be removed by a second distillation, which then leaves the pure essential oil, which is now known as the absolute. And typically jasmine and rose, these are extracted by the solvent extraction method, and so therefore they are typically known as the rose absolute or the jasmine absolutes. And the solvents used during the extraction process, they can be condensed, they can be rectified, and they can be reused for a second batch. Next, we come to distillation. So, distillation is probably the most popular method used to extract the essential oil from the plant materials. And this is commonly used for lavender oil, rose oil, cumin oil, you know, isolation. And here it involves the heating the volatile essential oil to its vapor state, followed by condensing into the liquid. Now, various distillation techniques can be used. These will include water or the hydrodistillation, steam distillation, and even hydrodiffusion distillation methods. But among all of them, steam distillation is going to be the most popular method. And in this method, the plant material, this is going to be placed in large distillation containers. These are commonly known as the stills. They have nearly a 600-gallon capacity tank which is lined with copper, and steam is then injected through an inlet into this plant material, into the stills, and then once injected, the distillation is carried out. The steam releases the essential oil from the plant material, after which it passes through a cooling system, that is the condenser, where the vapor mixture gets cooled and it gets collected. And here you can see once the two, it separates out and we are able to isolate the pure essential oil. And since in steam distillation the temperature, it never goes uh, beyond 100 degrees centigrade, so it can also be used to isolate those essential oils which are very sensitive to heat. And actually, compared to distillation using water or hydrodistillation, steam distillation, it has a much higher efficiency and the quality of the essential oil that is obtained is much better. Next, we come to enfleurage. So, enfleurage is actually one of the oldest methods of extraction of the essential oils from the flowers with the use of fats. And however, uh, with modern methods of extraction like solvent extraction and distillation, its popularity has now gone down, and the fats that are used for its isolation, they can either be a vegetable fat or they can be an animal fat. And actually the fat here, it is infused and sometimes when the fat, it is infused with the odor bearing compound, then it has a special name and it is known as enfleurage pomade. And depending upon whether heat is applied during this extraction process, the enfleurage is of two kinds, hot or cold enfleurage. So in the cold enfleurage method, for example, a large framed plate, usually a glass plate known as the chassis, this is going to be smeared or covered with a layer of this fat, and fresh plant raw materials, the flowers or the petals, are placed on the top of the fat and they are kept and allowed to rest for a few days. And with time, the scent diffuses into the fat. Now this process is repeated, meaning fresh petals are continuously going to be added till the fat becomes saturated with the odor bearing compound. And the final product, that is the fat saturated with this fragrant oil, it can either be used as is, then it is known as the enfleurage pomade, or we can dissolve the fat in an alcoholic solvent and allow the alcohol to evaporate to leave behind the pure absolute essential oil. In the hot enfleurage method, the same protocol is followed. Only difference is that slight heat or hot animal fat is going to be used. The major drawback of this is that the concentration of the essential oil or the odoriferous oil that is obtained, this is going to be usually very low. The next method is known as the expression method, and this is actually one of the most traditional methods of extraction of the essential oil. The expression method is also known as expeller pressed or the sponge process, and nowadays it is also known as the cold pressed method, especially because no heat is required during this extraction process. Uh, Now Mostly it is, or most commonly it is used for the extraction of those essential oils which can be obtained from the peels or the fruits of the plant, especially those oils obtained from the citrus family. So here traditionally what is done in the modern method, what is done is that the entire fruit is placed in a machine where where it is pricked. Pricked means that it is continuously, small holes are made on the peel, on the surface of the peel. Now, as this happens, the small sacs are the fruit's oil sacs. These continuously are going to get pierced. Now, as they get pierced, so the oil, it starts to get released, or the oil, essential oil, it releases. So the small sacs containing the essential oils, they will break open. It releases the oil. Water is then going to be sprayed over the fruit to collect the essential oil. And then at this stage, uh, uh, the essential oil, it is then going to be, it undergoes either filtration or centrifugation to separate out the pure essential oil from the water. And this method is particularly used, like I said, for fruits, essential oils which are obtained from the fruits of the citrus family. Besides these traditional methods, and with the increased interest in adopting cleaner and greener methods of separation, a new approach involving supercritical fluid extraction. This has gained much popularity in the food and flavoring industry. It is particularly used for the decaffeination of coffee and tea. And here what happens is, uh, the supercritical fluids, that are fluids which, when a compound exists above its critical point, it exists in a fluid-like state. That is, it is neither a liquid nor a gas. It exhibits properties which are characteristics both of the liquid, that is, it has a high solvating power, and properties of a gas, high diffusivity and low viscosity. Now, certain compounds like carbon dioxide, butane and ethylene, these are now commonly used in their supercritical state for various industrial applications. Among the three, carbon dioxide is going to be most important, and carbon dioxide, we know it is odorless, it is colorless, non-toxic, non-flammable, and it can be recycled, and its supercritical state is reached, you can see, very easily. So, extraction of essential oils using supercritical carbon dioxide, it provides a very attractive and what we call as a cleaner or a much more green approach for the isolation of various essential oils. Especially it is used for the isolation of the eucalyptus and the lavender oil. And the carbon dioxide extracts that are obtained, uh, these are much more pure, and the essential oils have a much better aroma and can be compared to those of the natural ones, and the much better results compared to those by the steam distillation methods. Uh, Typically, conventional extraction techniques like solvent extraction, distillation, even though they're very extensively used, they do have drawbacks. Low selectivity, they will require high energy requirements, we have to use solvents. So compared to that, the use of supercritical fluid extraction, this provides a much cleaner and greener approach. So in the supercritical fluid extraction, so usually what happens, it involves a semi-continuous batch process. So this is a semi-continuous batch process. The extraction vessel that we have, the extraction vessel, this is first charged with the dried and finely powdered plant material, after which the supercritical solvent, so in this case the supercritical carbon dioxide, is pumped into this extractor. Uh, it is pumped into this or loaded into this extractor vessel. The supercritical fluid along with the extracted plant extracts then exit the vessel through a depressurization valve into the separator. And now, due to the depressurization or due to the low pressure, the extracted essential oil then gets separated out from the gaseous carbon dioxide. And you can see that the gaseous carbon dioxide, it is again recycled and repumped into the plant feed, again by converting it into the supercritical carbon dioxide. And the separated essential oil, this is going to be collected. So the lavender essential oil, this is typically extracted using, for example, the supercritical carbon dioxide technique, and it provides good separation of the various odor bearing constituents which are commonly used. Even German chamomile flowers, these are also they are also going to their extraction of the German chamomile essential oil from the chamomile flowers. This is also done using the supercritical uh, carbon dioxide technique. Just very quickly, two very common essential oils which are used in India. One is the rose oil. This has many names: rose otto, attar of rose, rose absolute. It is most widely used in the perfume industry and the cosmetic industry. Uh, it is cultivated from two different types of roses, the Rosa damascena and the Rosa centifolia. And but the isolation of the rose oil, it is a very labor intensive process. It provides a very low content of rose oil, and nearly 3.5 tons of rose petals will produce only 1.36 kg of the rose otto. And the most common components of the rose oils are compounds like citronellol, phenyl ethyl alcohol, and then you have the various rose ionones. Uh, the major methods of extraction will be hydrodistillation and the solvent extraction process, and most commonly it is used uh, as we know in soaps, powders, creams. Nowadays all of these cosmetic products are all sold or marketed with a rose scent. And besides that, it does have certain medicinal values. They are anti-inflammatory and nourishing properties as well. and it is also known in certain references to possess antidepressant properties, and so therefore it is used in aromatherapy where it helps to soothe the mind. Next, we have sandalwood oil, one of the most expensive essential oils, very common in India. It consists mostly of sesquiterpene alcohols, including alpha-santalone and beta-santalone. And India is actually one of the highest producers of this sandalwood oil. It is typically done by hydrodistillation method of extraction. Steam distillation can also be used where superheated steam is passed through the heartwood or the sandalwood, and typically the steam distillation it yields 3.6% of the oil after 24 hours of distillation. It is an excellent, mild and long-lasting sweet fragrance. We know it is commonly used in perfumes and cosmetic products, and it also has antipyretic, antiseptic and diuretic properties, and it is also used for the treatment of headaches, stomachache and even UTI infections. It is mentioned as an Ayurvedic medicine. So with that, I would like to end my presentation. I would like to once again thank the organizers for inviting me to become a resource person. And before I end, I would like to invite you all to please come and visit Miranda House. We are an all-girls college, part of the University of Delhi. We have been ranked #1 for the last 6 years in a row for the NIRF rankings. We have an A++ grade from NAC. We have a DBT Star College status, and we also regularly conduct every year a summer intensive research program for the undergraduate students. So your students can definitely apply if interested. You can see we have very nice, modern, well-equipped labs, which I'm sure your students will enjoy if they come to work in. So please come, do visit us, and I would love to meet all of you. Thank you once again.
Thank you so much, ma'am, for such a wonderful talk on the chemistry of terpenes, terpenoids, and the essential oils. You have explained everything in such a beautiful way, in such a simple way that reflects that you are really in #1 college, that is the Miranda House, University of Delhi, Delhi. And you have explained everything, practically you have explained everything in such a way that every participants giving their views, giving their feedback simultaneously to us. Okay, that lecture is very beautiful, very nice, well explained by the ma'am. So thank you so much, ma'am, for sparing your valuable time for our participants. And I again welcome you, ma'am, for the next different sessions which are being organized by our college in different type of programs. You always be most welcomed, ma'am. So I give my sincere thanks from my college fraternity, from Department of Chemistry, from the Department of Higher Education, Haryana, from our principal side also. Okay, you give such a nice lecture and spares your valuable time for our participants. So thank you so much, ma'am.